Okay, so Leetcode practice time. So in this video, there are two goals. The first one is to see how to solve this problem. Find a solution for this problem and put some solid code there. And the second one is to see how to solve this problem properly during interview by going through the interview process. So let's get started. So in the interview, the first one, remember always, is to understand the problem and ask clarification questions in case you have something that is unclear to you, and also think about the edge cases that are pretty special and you need to take special care of. So let's read through this problem. So binary tree maximum path sum. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes is a sequence has an edge connecting to them, and a node can only appear in a sequence at most once. Note that the path doesn't need to pass through the root, and the path sum of the path is the sum of the node's value in the path. And given the root of the binary tree, return the maximum path sum of any path. So let's take a look. For this one, 1, 2, 3. This tree, it is going to output 6 because there's a path from 2 to 1 to 3, okay? And for this one, let's see, maximum, so for this one, maximum path sum is going to be 42 because there is a path from 15 to 20 to 7, okay? So I think I pretty much get it. So remember me a similar question, something like you find the longest path, the length of the longest path within a binary tree. It's just similar, I would say. So after we figure out what the question is asking us to do, the next step is to find a solution. So for this one, what we could do is we could use recursion. We could use something similar to DFS. So we will define a function. Let's just call it DFS. So for this one, it is going to return a integer, and the integer is it is going to return a path including the root node, but either by just going through the left subtree or the right subtree. So for this one, so it is going to return. Okay, so a path, so max value, max sum of a path including root, but either going through left or right subtree. So it's not like the path defined here. For this function, it's only trying to see, so it is going to try to search the maximum path by just going all the way to the left subtree or going through the right subtree, and then plus the value of the node. So for this one, and then during this DFS time, since we are going to traversal on the left subtree and the right subtree, we are going to keep a global variable. Let's say max sum would be equal to max sum max sum. So it would be node dot value plus DFS root dot left DFS root dot right. So something like this. And the runtime for this solution is going to be O of n, and is the number of the nodes within the tree. and so space-wise is going to be linear to the height of the tree. Okay, so this is the time and this is the space. So let's get started to do some coding. So after you are done with the solution finding part and you feel comfortable, both your interviewer and you feel comfortable about this approach, it's time for us to put some solid code there. So in the coding part, speed is a thing that is a factor to be considered, and also the correctness, and of course the readability. So all in all, it is to see your ability to turn your idea into the code. So let's get started. So we will define a let's define it as private. So let's say max sum. This one would be, I would say, we will initialize it here. So max sum is equal to a 0, and we are going to call DFS. So what if the root is a empty thing? So it didn't say that the root couldn't be empty. Okay, so it says that the number of nodes in the tree is in the range of 1. So okay, so the tree wouldn't be empty, so we don't need to consider this edge case at this moment. We will just call it DFS root, and we are going to return max sum. All right. So we will define a function here. Let's see. So this we will pass it like a tree node as root. So if the root is a non-pointer, then we just return 0. So first of all, we will see what is the, so we will try to see what would be the gain from the left subtree if we can find some paths on the left tree that can give us some gain on the max sum. So let's say max left gain is equal to mass dot max 0 and DFS root dot left. Okay, and the right gain would be equal to mass dot max 0 DFS root dot right. It is because if everything on the left part, for example, for a certain root, if every number on the left subtree is negative, then we actually don't need to get any pass from the left subtree because the pass is going to give us some negative value, which doesn't add on, which doesn't give us any gain for the max sum, which is what we are trying to find. So here we would say max sum is equal to max. Okay, so this one we actually should initialize as root value. Okay, so it's mass dot max sum left gain and the right gain. Okay, and then what should we return? We should return root dot value plus mass dot max left gain or right gain. So if left out, so for example, if we cannot find any pass with the sum on the left part to be positive, then we can simply drop that. Same for the right subtree search. If it turns out that we cannot find anything on the left subtree or right subtree that has a sum to be larger than 0, then actually it is better we just keep the root node. So that's the best option. Okay, so I think we are pretty much done about coding. So the next part is about testing. So testing part, first going through this piece of code to do some sanity check, and then think about some test cases to increase the test coverage. So let's take example 2. Let's take a look at the example 2 by going through this piece of code. So first of all, max sum is equal to so we will keep record max sum currently is equal to -10, and we call DFS on the root. So root is not equal to none. So left gain, we are going to call DFS on the left root. So it's here, and it's not equal to none. Left gain is going to return 0 because the left subtree for this node is none, and same for the right node. So after all, it is going to return 9 plus 0, which is going to be 9. And then let's see the right. Then it is going to call the DFS on the right subtree of this root node, which is going to jump into here. So we will see. Okay, so actually after calling that one, the maximum is going to be 9 because we have finished traversal the left and right subtree, and then we update the maximum there. And so it is going to step into here. For this one, similarly return 15. So you're going to get this updated to 15 and this updated to 7 when we finish traversing for this node. And then after the left gain and right gain return, we are going to see, okay, so this one, it's actually, there is some typo, dot value plus, okay. Yeah, so maximum is okay, and then we are going to see, okay, the left gain is going to be 15, right gain is going to be 7 plus the root node, which is 20. Then it is going to give us 42. Okay, it's going to give us 42. And then the final thing, the left gain for this node, the left gain is going to be 9, and right is going to be 42, and it is going to be 41 for this value, the root value plus left gain plus right gain. And then maximum currently is 42, so we don't need to update it. Okay, so I think it should be okay. Well, okay, so I think there is one place I give you the wrong idea, because when we finish calling this one, which is root.dfs on root.right, when the root is this one, it's actually going to give us the root node, which is 20 plus the maximum from the left or the right. So it is going to be 15 plus 20, which is so the right gain is going to be 35 when root is equal to this one. So 35 plus the left gain, which is 9, and plus minus 10. So that's the part I explained by fault. But overall, I think the correctness looks fine. Okay, so let's give it a submission. Okay, so we are good about this problem. So like I said, for task case setup, definitely set some task case with some negative values. For example, if I want to set up some task cases, I would set up a tree which contains negative integers from the left tree and negative integers from the right tree, so that for this maximum it could either return 0 or return the value from DFS calling on the root.left. So the principle to add task case is to make sure that we cover different branches, to make sure that coverage is as much as 100%. So that's it for this question. If you feel it a bit helpful, please give me a thumb up, and I'll see you next time. Thanks for watching.